Let me demonstrate real quick what you're going to learn about integers and floats in Power Automate. I have an integer and a float initialized in this flow here and here. I have integers here, I have floats here, and I'm going to talk about some limitations with float values. And then down here I do a do until, and I use an increment to make this flow do this until start equals end. So start is 0, end is 5, and I'm going to test this flow. And there we go. This ran 5 times. So if I wanted something to run 5 times, I could do this action down here, another action step, and I could increment that variable. We'll talk about that. We'll also talk about what it means to be off by 1, which is a very common error. And anytime you're programming, off by 1 is a very common error. My name is Dana. I've been using Power Automate for years to automate various aspects of a luxury golf brand business. I'm happy to share some of these tips and tricks with you all. As I've learned them over the years, I've come to find out there's limitations, there's nuances to working with Power Automate. Let's go and let's talk about using variables, specifically the float and the integer, and how they might be used in your flow. First thing I'm going to do is I'm going to open up Power Automate. I'm going to start from scratch so you can follow along. So I'm going to Power Automate, and we're going to hit Create on the left-hand side. We're going to choose a Instant Cloud Flow, but I'm also going to hit Skip. I always like to start with a blank slate, so let's just hit Skip on the little tutorial to get you started, and let's just start with a blank slate. First thing I'm going to do is add a trigger. What I need is a manual trigger, so I'm going to do manual here. I'm going to type that into the little search. I'm going to click Manually Trigger a Flow. All right, so this is the baseline that I typically get started with in my videos. I just like to start with a nice, clean, fresh slate when I build a flow. Now, we're going to work with 2 types of variables today. So we're going to hit the plus sign, add action, and we're going to type in variable here, singular, because it shows up on the list as variable. So, well, I guess if I add a S, it shows up there as well, but I typically try and search them as I know they're going to appear on the list. So we have set variable, decrement, and initialize here that are showing up. There's see more. There's more options here, but we need to initialize a variable before we can use it anywhere in the flow. So I'm going to use initialize variable, and let's be descriptive here. It's kind of like self-commenting code. So let's do init, and let's say this one is the integer, and let's call this start. And let's refer to this as an integer. And let's give it a starting value. When you initialize, you can really just declare it, and that's it without a value. But anytime you call it in your flow, it's got to have a value associated with it. So let's start this value as 0. All right, and hit save. And let's also initialize another variable here. Let's call this one a float. So initialize variable, and let's do init. It's interesting that it copied my name over automatically, but I'm going to call, you have to have it called something unique here. So let's call this one float, and let's do a float. And let's call the initial value 1.5. Now, as I save this, I'm going to show you how to do this the wrong way, and that would be if you were going to initialize a variable as a integer with a decimal value. You don't want to do that. So if we say 1.5 here for the integer, see it says invalid parameters. It does not like that. Okay, well let's say 1.0. Does that work? Let's save that. No, does not work. It needs to be just a whole number. So integer, whole number. Remember that. Float, anytime you want a decimal, use a float. Now I'm going to show you a limitation here with the float. So let's say we wanted a float value to be a really long number. So let's do 1.123456789 So that's 10 places. 123456789 So that's 20 places. And let's hit save. Let's test, manual, test, run. Now, I'm not going to show you, when I say test, that is the process I'm going through. I'm going through test, manual, test, and run. I'm not going to show you that every time. I'm going to skip that here as we go through the rest. So when I say I'm going to test and run it, that's what I'm going to do, those steps that I just showed you right there. Okay, so let's look at this integer, and the integer says, hey, it's got a value of 1. Well, that's cool. Let's look at the float. Ooh, what happened here? The float got cut off. So we have what looks like 17 places here to the right of the 0, and we have 1 place to the left of the 0. So that gave us a total of 18 places. Well, that's interesting to note. So what happens if we make this value here? Let's make this this value 1,000. What happens there? So 1,000.12345, etc. So let's try that. Okay, now it cut off some more places. We see that? We had 5, 6, 7 here before on the end, but now because we've made this longer, this decimal is getting shorter. Now, for the most part, you're not going to come up against this as you're running flows for automation. You're probably not going to be working with these insanely huge numbers that are going to affect your decimal place. But let me show you, like, let's go to the extreme here. So let's add those numbers back on there, 5, 6, 7, 8, 9, 0. So now we have 20 places. And so that's 1,000. Million, billion, trillion, quadrillion. And let's save that. Well, that is interesting now. Look at this. It gave us just the 1 decimal place. But it's important for you to understand that there are limitations if you're doing this for highly accurate scientific work or statistical work or something, that you just need to know that there are some limitations with this. Okay, let's talk about incrementing, which is very handy. And let's add an increment here. That's all I'm going to do with floats, by the way, on this. So let me just drop that action. I'm not going to do any more with floats today. But you can multiply, add, divide, all of that. You can do that in math, in functions. We'll get to functions, some functions later where that might be useful. But let's take this integer that we called start, and we said that was let's start at a value of 0 and save. And we should have a 0 here. So let's add an action, and let's do initialize variable. And let's call this one init end integer 5, save. And just so we don't get confused here, I'm actually going to do this one. I'm going to call this init start. As descriptive as you can as you're writing your flows will make it easier for you in the future. So if you see a bunch of initialized variables, 1, 2, 3, and it will literally say something like initialize variable 1, initialize variable 2, then you're going to find yourself clicking on them to figure out which ones they are. So if you can be descriptive here in this little description box, then that's going to help you down the road. So what can we do with this now that we have a start and an end? Well, let's try an increment, which is pretty cool. Increment variable, and let's do increment start. And we pick start, and we say we're going to increment it by 1. Save, and then test it. And down here in the results, we'll see that we have now the name start had an output of 1, right? Because we started with 0 and now we're at 1. All right, well, that's cool. So what else can we do with this? We can also do a decrement. So there's other ways to handle this, like you can add numbers together to make this happen, but it's very cool and convenient that there's an increment and decrement in here, just like you would have an increment and decrement that you can use in most programming languages. So let's decrement start back to 0 again. So let's do decrement by 1 start, and let's do decrement start as the descriptor, save, and then test that. So we have started at 0, we incremented it to 1, and then we decremented it back to 0. Okay, well, that's cool. But where can we do this with something super useful inside maybe some sort of a loop? So now what I'm going to do is I'm going to add an action. This action is going to fall under the control options, so we can see different control options here. Let's do the do until, which is basically a while loop. So do until, and now we can choose something here. So I know my function is little bit cut off here on the left-hand side of my screen, but if you click function, dynamic content, we can say do until start is equal to function dynamic content end. So let's do that and save. So what happens if we run this right now? This would run up to 60 times, or it would run to this timeout, which is PT1H. This is in a ISO 8601 format, and you can look that up, but we're not going to get into that too much here. So now let's add our increment here. So if we increment start here by 1, save this and run it, what happens? Well, here now we see that it ran it 5 times, right? 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, every time incrementing. Here is where you can get into the off by 1 error, which would be if I wanted it to run 5 times, but I actually was thinking about my start here being 1, because if I did that, this would only run 4 times, right? Or if the number is including the last number, you know, and you go 0 through 5, you're going to end up with 6. So you have to think about how many times and how many increments and where the increment is in relation to the steps in your flow. If you increment and it stops your flow, you just have to think about your steps. You just got to think about, and that's going to come with some experience, trial and error, and thinking about where you place that. And as you place it, keep an eye on things like the amount of times that a flow runs to make sure that you're not, you know, because if we said here, you know, until it reaches, we could say here, we could say in this as well, we could say in this do until loop. Now, by the way, most actions you're going to click here at the top of the action. In a loop action, conditions and things like that, you typically click up in here, and then on the do until is actually at the bottom, do until this. So here we could actually just put a number in here, right? Now, what would happen if we said 5.0 until start is equal to 5.0 and save that? So I'm running it right now, and it's just running. Because guess what? Oh, there we go. It said it reached the high count of 60. So it went way past the 5.0 because 5 does not equal 5.0. That's good for you to understand. Now, we could have done it this way. We could have done, let's turn this into a function. And if we said integer of 5.0, because it wants a string that is fed in here. So let's do integer of, and let's do a single quote here. Let's add that and save and test that. And that one worked perfect. We got a 1 through 5 here, 1 of 5. So that one worked excellent because we now have reconditioned the variable. We've changed its type into something that's compatible for comparison. When you compare variables, you want to go type for type. So if something's a string, convert something else to a string if you have to, in order to make it be the same type that you're comparing. Okay, I think that's it for this one. I hope that you find this helpful. Please let me know in the comments if there's some other feature inside Power Automate that you would like to look at. Last time we did Booleans, and this time we learned about initializing and using those integers and float variables inside Power Automate. I hope that you find this helpful. Have a great day.